Hello everyone, this is our today's Leetcode problem of the day, minimum index of a valid splits. Okay, uh, the question saying that we have to given an element x of an integer arr of length m, and each dominant means if an element x will be dominant if more than half the element of array have a value of x. Okay, means the number of elements present in my array, uh, a number x will be dominant if it's present more than half times. Okay, you have to given zero index array nums with one dominant element. Okay, you have to gain only one dominant element is possible, and we can split my array into two. We have to split into my array two parts, from 0 to I and I plus 1 to n, such that such that the dominant element in first and second part should be same. Like if my first part having dominant element of 2, so in my second part 2 should be dominant. uh, Here nums of I and nums of I to j represent uh, a subarray starting with index I and ending at index j. Okay, particularly if j less than I, then nums of I to j denotes an empty subarray. Okay, we have to return the minimum index of valid split. Like there are possibility of more than one splits, so we have to return the minimum index, and if we do not find any particular splits, so we have to just return the -1. Okay, I hope you understand the problem. This is our problem. So what we have to return, that is, if we find that like let's say the example of this. Okay, this is my first example. Here 2 is present more than half of the length of the array, means 2 is present more than 2 times. Okay, so 2 will be dominant, so we have to just split my array into two parts such that the length of the dominant element in each part should be same dominant element. So if I divide from here at index 1, sorry, at index 2, so this part contains the frequency of 2 twice, and this part contains the frequency of 2 once. That is more than the half of the length of the my array, means 2 is dominant in both the part of the my subarray, means after splitting. So we have to just return the minimum index. So this index is possible, so I will just return the 2 index. If there are multiple index possible, so I have to return the minimum index. Okay, I hope you understand the problem. Let's read the second example. Okay, example of number third. This is our example. Okay, in which the array length having size of 7, and the element 3 come 4 times. So 3 comes more than the length of the my array. Okay, like more than half of the length of the my array, means half of the length of array will be 7 by 2, that will be 3, and my 3 comes 4 times. So yeah, 3 will be dominant element. Let's see, try to splitting up and using the approach. What I have to do, I will go to each and every index, and I will check that the frequency present in my this size of subarray, and the remaining frequency of my will be in the this subarray, means standing at index I will check two subarray from 0 to I and I plus 1 to n. If I know that 0 to I the frequency of the ith element is x, and from I plus 1 to n the frequency of ith element will be total frequency minus current. Okay, so total frequency minus current will be the frequency of right side, the frequency of dominant element in right side of array. Okay, so what I will do, I will check that if I can split it in such a way that my array length is the frequency of dominant element is greater than half of the length of the my array. So length of the array will be from 0 to I will be I plus 1. So I will check that if I plus 1 by 2 is less than or equals to my frequency of element, and the another size of array will be n minus I minus 1. So I will check if n minus I minus 1 by 2 is less than or equals to my the frequency of dominant element in right side of the array. If it is if both the condition will be true for any index, I will return the index. Since I am iterating from the left side, the index will be minimum. After that, if we did not find any element, I will just return the minus 1. I hope you understand this problem. Let's understand the first example, in which if I am standing at here, I will check that if 3 is dominant in this or not. Since 3 is a dominant element, 3 is dominant in this subarray, but 3 is not dominant. Like here the array length will be 6, but my 3 only comes thrice, means that will be my length by 2, but dominant element should present more than length by 2. Okay, more than half of the length. So here 3 is not let's take this subarray. So here 3 is dominant in left part, but again 3 is not dominant in the right part. As you can calculate, like our array size is 5 and half of the 5 will be 2, but our dominant element comes only twice. It should become more than 2, but it is equal to 2, so it is again not dominant index. So after that, iterating each and every index, I will not able to find any index where we can split my array into two parts such that the same element will be dominant element in the both the two parts. So we'll just return the minus 1. Hope you understand it. Let's try to code it. Since as you know, we are talking about the frequencies, and so what I will do, I will take a map in which I will count the frequency, and I will let's first take the map for counting the frequency, and there will be a dominant element int dominant, let's say value minus. Okay, for auto it is equals to none, I will iterate my array, and what I will do, I will increase the count of occurrence of it, means current element, after I am going to that element. Okay, and what I will do, I will also take a maxi, that is my that will be 0. Okay, so if our maxi is less than frequency of the current element, means our current element is more dominant. So what I will do, I will mark my current element, I will assign the frequency to the I will do maxi equals to a map of it, means I am assigning since my maxi is lesser, so I am just assigning the frequency which is maximum at current. Okay, that will be mp of it, and what I will do, my dominant element will be it because it has more frequency. After that, I found my current dominant element. Okay, then I will traverse my each index from 0 to I less than, I will go to n minus 1 because I have to divide in the left side and right side also. So any of the part cannot be empty. Okay, so the frequency till current. So what I will do, I will make empty domain equals to 0, and since maximum frequency will be stored by here, so I will just know the maximum frequency of dominant. Why I am making the frequency of my current dominant element equals to 0, because I am traversing from the left side and I have to store the frequency of dominant element on the left side. I will also can take the count variable, let's say int count. Okay, if I am reaching element that is equals to dominant, so if my nums of I is equals to dominant, so I will just increase the count plus plus. Okay, so and if any index, I found that if if my count, if my basically our size of the array by 2 should be less than or equals, since it should be less than not equals to count, means our frequency should be greater than half of the length and maxi minus count. Okay, so maxi minus count, if maxi minus count is greater than my array size will be n minus i minus 1, I think. Okay, so I'll just return the I. After the traversal, if I am not able to find any index, I'll just return -1. Okay, so let me check the condition first. Okay, I plus 1, yeah. So what will be left side of it is 4 minus 0 minus 1 minus 3. Yeah, this is true. Okay, so since you are dividing here, so element will not able to compare in correct order, because like condition, let's try to find the odd for odd length. Odd by 2 will give me like 5 by 2 will give me 2. So what I will do, I will just transform my 2 into count. Okay, so it will give me the correct it will give me the correct calculation, and I think my code should run for the test case. Let's try to run the code. I am not initialize the n, my will be num dot size. Okay, yeah, my code is accepted. Let's try to submit it. Yeah, my code is accepted. Okay, you can since in this operation we are doing traversing 2 times, so time complexity will be O of n, and the space complexity will also be O of n, since I am storing the element in the map. But if interviewer will ask that do it in O of 1 space. Okay, so for doing in O of 1 space, I do not have to use map. So since as we know that for finding the any element present in my array more than half of the length, we use Boyce-Moore voting algorithm. Okay, so what Boyce-Moore voting algorithm says that in Boyce voting algorithm, I first take my count, that is I will initialize with 1 and my num is equals to 0. Like what I assume that my first element is my dominant element. Okay, so I'll just take my first element as a dominant element, and if I am going to the next index, and if this element is equals to dominant element, so I will just increase the count. If this element is not dominant element, I will decrease the count. Okay, so after decreasing, if I reaches the 0, means this element cannot be dominant element. So what I will do, I will make that my current element is my dominant element, and I will just increase the count. Since my current element will be dominant element and it is present once, so I will just increase the count again. Okay, so after the end of the traversal, it will give me the dominant element in my array, and after since if I able to find the dominant element of my array, so I can also find it easily the frequency of my array, how many times dominant is present, just by using counting. Then all the other things will be remain the same, because you do not have to do anything else. Okay, let's try to do it using the Boyce-Moore voting algorithm. I hope you know about this algorithm. So let's say my dominant element is my current element, that will be 0, and my count of frequency will be 1. Okay, so I am going to my element. So what I will do, if my current element is equals to my dominant element, I will just increase the count, else I will just decrease the count. Okay, and if my count will be 0, means count will only be 0 if I am decreasing. Okay, so after decreasing I know that the element which is dominant cannot be dominant element because it reaches the count 0. So I will mark my current element with the dominant element. Okay, and since it is present, I am standing at this dominant element, so it having the count of 1. Okay, I hope you understand this. Then again what I will do, I will go to for int I is equals to 0 to I less than n I plus plus, if my nums of I is equals to dominant. Okay, I will just increase the count. Sorry, it will be max c. I will just increase the max c. Max c will represent my total total times my dominant element present in my array. Okay. Okay, I hope you understand the problem. Let's try to submit it. Okay, my code is accepted. So I hope you understand. Time complexity will be still O of n and space complexity will be O of n. This will be most optimal approach for the interviews. Okay, hope you understand it. Let's end the video.